Namaste, welcome on the channel. So today we will discuss the chapter solutions from class 12. First of all, we will discuss the term solution. So what is solution? How will we define the term solution? Solution is a mixture of two or more components, which are mixed together and they are chemically non-reactive with each. They should not react chemically with each. So they are chemically unreactive with each other. This is called as solution. So how can we express the concentration of the solution? For expressing the concentration of the solution, we need some terms. What are these terms? Let us discuss all these terms one by one. First of all, we will discuss the term percentage. Percentage in terms of mass by mass, mass by volume, and volume by volume. So what are these three terms in terms of percentage? How will you express the concentration of the solution? So first term is mass by mass. It is equal to the mass of any one component in the solution. Okay? So mass of any one component in the solution, is divided by mass of the solution into 100. Similarly, let us discuss the second term percentage by in terms of mass by volume. How will you define this term? How will you solve the questions related to this term? So mass by volume is equal to mass of any one component in the solution, mass of any one component in the solution, and it is divided by volume of the solution taken in ml. Okay, taken in ml, and take its percentage by multiplying it with 100. So it is mass by volume percentage, mass of any one component divided by volume of the solution, that is total volume of the solution into 100. And the third term is percentage in terms of volume by volume. So what is the third term? So mass of any one component in the solution, that is we are taking in the first two terms, we will replace the mass of the component with volume of that component. Okay, we will replace the mass with volume of one component in the solution divided by total volume of the solution. Total volume of the solution multiplied with 100. So these are the three terms to express the concentration of the solution in terms of percentage. Let us discuss the second term. So the second term is strength. How can we define the strength of the solution? Let us discuss this term. To define the strength of the solution, we need the mass of the solute in grams. Mass of solute. There are two components in the solution. One is solute, other is solvent. Okay, so mass of solute is taken in grams and it is divided by volume of the solution. And it will be taken in liters. Remember, 1 liter is equal to 1 decimeter cube. Okay, and the units of strength will be gram per liter. Okay, so this will be the unit of strength. This is the second term to express the concentration of the solution. Let us discuss the third term. The third term is molarity. So how can we express the term molarity? Molarity is equal to the number of moles of solute divided by volume of the solution in liters. Okay, so number of moles of solute divided by volume of the solution in liters is called molarity. So how will you make the moles of solute? To make the moles of solute divide the mass of solute with its molar mass or molecular mass. Okay, mass of solute divided by molecular mass. Mass of solute divided by molecular mass is called as moles of solute, and then divide it by volume of the solution taken in liters. So what will be the units of molarity? It will be moles per liter. So the units will be moles per liter, or it may be expressed as capital M, molarity. So this is the third term that we are taking here in terms of expressing the concentration of the solution, moles per liter, capital M. Let us discuss this term with an example. So take the example of an acid. Suppose sulfuric acid we are taking here. So suppose we have to calculate the molarity of a solution of 4.9 grams of sulfuric acid. Okay, have to calculate the molarity here of 4.9 grams of sulfuric acid if it is dissolved in 500 centimeter cube of the solution. 500 centimeter cube of the solution. Then what will be the molarity of the solution? So this is the question that we have to calculate. What will be the molarity of the solution if 4.9 gram of H2SO4 is dissolved in 500 centimeter cube of the solution? So let us see how we will solve it. So first of all, to calculate molarity, what we need, the number of moles of solute. Okay? And to make the number of moles of solute, we have to divide the mass of the solute with its molecular mass. Mass of the solute is already given here. We have to calculate the molecular mass of the solute, which is H2SO4. So what is the molar mass of H2SO4? What is the molecular mass of H2SO4? See, so it is equal to 2 plus 32 plus 64, 16 into 4, 64. So it will be equal to 98. So 98 AMU will be the molar mass of H2SO4. How will we calculate the molarity of the solution? Now, first of all, calculate the number of moles and then divide it by the volume of the solution. Let us calculate here. So molarity will be equal to 4.9 grams of solute divided by 98 AMU of H2SO4, and this is the number of moles of H2SO4 which we will divide by volume of the solution taken in liters. So 500 centimeter cube. It is 500 centimeter cube. What does this mean? What does this mean, students? 1 centimeter cube is equal to 1 ml. We have to convert it into liters. So to convert into liters, we have to divide it by 1000. Okay. Now it will be equal to 4.9 divided by 98 into 1000 by 500, and this will be equal to how much? Will be equal to 0.1 mole per liter, or capital M, molar. Okay, so this is the molarity. Okay, so this is molarity of the solution, and this is the simplest of the numerical that we have solved for the calculation of molarities. Let us discuss the next term, which is normality. Normality. What is normality? So let us discuss the term normality. What is normality? Normality is equal to the number of gram equivalents. It is expressed by capital N, and it is equal to the number of gram equivalents. Number of gram equivalents dissolved per liter of the solution. This means we have to make the gram equivalents of the solute and then divide it with volume of the solution taken in liters. Okay. So this will be the normality of the solution. Now to calculate the number of gram equivalents, how will you calculate this term, number of gram equivalents? This is the important term. Okay, so let us discuss how will you calculate the number of gram equivalents of any solute. Let us discuss here some of the major points to calculate the number of gram equivalents. The first is, suppose um, uh, this is number of gram equivalents, which is equal to mass of solute divided by equivalent mass. Okay, it is simple. Mass of solute divided by equivalent mass is equal to number of gram equivalents. You will put the value here and divide by volume of the solution in liter, and you will get normality of the solution. But how will you calculate this equivalent mass of any solute? And to calculate this equivalent mass, suppose we want to calculate the equivalent mass of an element. Okay, suppose we want to calculate the equivalent mass of an element, then you have to divide the atomic mass of the element with its valency. Divide atomic mass with its valency. Okay, we will get equivalent mass of the element. Suppose we want to calculate the equivalent mass of an acid, then how will you calculate equivalent mass of an acid? Then how will you calculate the equivalent mass of an acid? So first of all, calculate the molar mass of acid, molecular mass of acid, and divide it with the basicity of the acid. Now, what is basicity? Suppose we are taking the example of H2SO4. When it gives the ion in the solution, it gives 2H plus and one sulfate ion in the solution. So the basicity of the solution here is 2. So we will divide the molecular mass of the acid with basicity. This is the way how you can calculate the equivalent mass of an acid. And similarly, you can calculate the equivalent mass of a base. Okay? Apply the same method for calculating the equivalent mass of base by dividing the molecular mass of base with acidity. Okay? So these are few methods of calculating equivalent mass, and normality is equal to number of gram equivalents. How to make the number of gram equivalents here? Divide the mass of solute with equivalent mass. You will get number of gram equivalents and then divide it with the volume of the solution, which is taken in liters. So the unit of normality will become gram per liter. A gram equivalent per liter. Gram equivalent per liter will be the unit of normality, or simply capital N will be the unit of normality. Okay. So this is the question that we can solve for normality. Let us discuss one example here. Suppose we have given 0.49 gram of sulfuric acid H2SO4, which is dissolved in 250 centimeter cube of the solution. Okay, 0.49 gram of H2SO4 dissolved in 250 centimeter cube of the solution. Then calculate the normality of the solution. How will you calculate the normality of the solution? As we have already seen in case of molarity, there we have calculated the number of moles. Here we will calculate the number of gram equivalent. So how to calculate the number of gram equivalents? First, calculate the number of gram equivalents. How to calculate the number of gram equivalents? Because acid is given. So first of all, you will take the mass of the solute and then divide it with the number of H plus which are released in. So it is 2. So divide 0.49 by 2. Okay, and this will give 0.49 is the mass of the solute, and it will be divided by equivalent mass. To calculate equivalent mass, you have to divide the molecular mass, which is 98 for H2SO4, by 2. Okay, because the basicity of the acid is 2, we will divide the molecular mass by 2 and we will get 49 equivalent mass. Now put the value here, 0.49 divided by 49, and it will be the number of gram equivalents. Now how to calculate the value of normality? Put all the values here. 0.49 divided by 49, which is equal to the number of gram equivalents, and then divide by the volume of the solution. Here it is given in 1 centimeter cube. I have already told you that 1 centimeter cube is equal to 1 ml. So it is 250 ml. We have to convert 250 ml into liters. How will you convert? So divide 250 ml by 1000, and here you will get 0.49 divided by 49 into 1000 by 250. This is how the calculation will be done, and finally you will get the answer 0.04 gram per equivalent, gram equivalent per liter. This will be the unit of normality. You will always write the unit with your answer. Okay, so this is the fourth term that we have discussed here with an example, which is normality. Okay, let us discuss the next term, which is molality. So what is molality? This is the fifth term we are taking here, which is molality. What is molality? How can we calculate the molality of the solution, which is expressed as small m? Okay, molarity is expressed as capital M and molality is expressed as small m. So it is equal to number of moles of solute. It is equal to number of moles of solute divided by mass of solvent in kg, divided by mass of solvent in kg. Okay, so this will be molality of the solution, and the units will be number of moles of solute divided by mass of solvent in kg. Units will be mole per kg, okay, or molal. Mole per kg or small molal units will be expressed in terms of mole per kg or small m. This will be the unit of molality. Okay, so let us discuss molality with an example here. Take the example of anhydrous sodium carbonate, whose molecular mass is Na2CO3 is having a molecular mass 106, and it is taken equal to, the mass is taken as 1.325 gram. Okay, the mass of the solute is taken as 1.325 gram. It is dissolved in 250 gram of the solvent, which is water. Is dissolved in 250 gram of solvent, which is water. Then calculate the value of molality, small m. How will you calculate the value of molality here? Okay, so let us see how will you calculate the value of molality. First of all, we will calculate the number of moles of solute. So we will divide the mass of the solute, which is 1.325, divided it with the molecular mass 106 gram per mole, and this will be the number of moles. We will divide it with the mass of the solvent. Mass of the solvent is 250 gram, then divided it with 1000 to convert into kg, and this will be equal to 1.325 divided by 106 into 1000 by 250. Okay, so the answer will be equal to 0.05 mole per kg or molal. It will be the molality of the solution. Molality of the solution. Okay, 0.05 mole per kg will be the molality of the given solution. So this is the molality term in which we can express the concentration of the solution. Let us discuss next the new term, which is mole fraction. Mole fraction. What is mole fraction? What is mole fraction? What is mole fraction? Mole fraction is equal to the number of moles of any one component in the solution divided by the total number of moles present in the solution. Suppose we are having two components in the solution, 1 and 2. There is a binary mixture and we are having two components, 1 and 2. Okay, so the number of moles of first component divided by the total number of moles will be equal to the mole fraction of first component, and the mole fraction of the second component will be equal to unity minus mole fraction of first component. Or you can calculate it either as N2 divided by total number of moles, but there is no need to calculate it again. We can subtract the value from unity. Okay, subtract the value of first mole fraction from unity to get the mole fraction of another component in the solution. This is mole fraction. If you are having more than two components present in the solution, then calculate the two values of different components and subtract the third mole fraction value from the sum of the other two mole fraction values. Okay, so in total, all the mole fractions present in the solution is equal to unity. It may be x1 plus x2 or x1 plus x2 plus x3. This will be always equal to unity. It will be always equal to unity. This is called as mole fraction. Okay, so these are the 6 terms which we have discussed today